orbital for the p's looks like that. Whoops. Looks like that, right? A figure 8. So, my question to you, does one orbital get really dark first, or do each of the 3p orbitals get darker? See what I mean? I'm asking you, does one orbital become really dark, and then the second p orbital gets really dark?
Well, no, because like they have to, all of them have to fill up once before they can double up.
Okay, so therefore, the 3 individual p orbitals get a little bit darker, and then they get darker even still. So 1 in each orbital first. I'm expecting you to know whose rule that follows. There's 3 rules to filling orbitals: Aufbau, Hun, Pauli exclusion. You need to know the 3 of them, okay? And you need to know which one is which. Now, do you have any questions about the videos that you watched? What's wrong with this? Well, I like that you did both. You showed both ways, long form and short. That's great because it shows for both. Some people did long, some people did short. What I would recommend you do is you add just one little part. You label it. And then you put the colon. Okay? But that's not why it's wrong. That's just something that makes it better. So, what does this actually look like? This looks like, here's our 4s. Okay, so what they've actually found is that one of these 4s electrons actually goes in to the 3d orbital. So that you end up with (3d10) and a 4s1. And this is because a completely full d orbital is actually lower in energy than a full 4s orbital with an almost full 3d orbital. When you fill orbitals, when you gain or lose electrons, it's always to get the most stable energy possible. And they found that when you're 1 electron short of having a full 4s and 3d, or a 5s and 4d, it will borrow 1 electron from the 4s orbital and put it into the 3d orbital. And that's lower in energy. And that's why copper can form a 1+ ion, because it loses it from here. Some of them will have it in there, and it will lose those too. Okay, so that's why it can do that. This is not excited. This is not an excited atom. This is just lower, not atom, although atom's always excited. He just reins it in really well. So this is not excited, this is very stable. It's lower in energy. So, any questions about that? So this would be the 4s1 3d10.
Does it apply to like all the higher level energies as well? Like
It's going to be anything that is in the same column as copper. So find on your periodic table copper.
Silver and gold.
Silver and gold. What charge does silver always make? 1+. It loses it from its s orbital. Remember last year we talked about, write these in. Zinc's always 2+, and silver's always 1+. It's 1+ because it loses 1 electron from the 4s orbital. What about zinc? 2+, because it is 4s2, 3d10, so it loses 2 electrons from the 4s orbital. See, this is why we have those specific charges when you lose electrons. It's because which orbital it's actually contained in. So thanks for putting this one up. Here, you're 1 short of being half full. Again, being half full in a d orbital is lower in energy than being full in an s, partially full in a d. So a half-filled d orbital, or a full d orbital is lower in energy. It's lower in energy. But you can only do this if you are 1 short. So you can't do it if you're 2 short of being full. So if you're 4s2, 3d3, that's what you got, okay? So what other elements are going to fill in like this? Molybdenum?
And then tungsten.
Can't say it either. Tungsten, yeah. Awesome. Once you've done the 2s, you're still on the second row. Where do you read to now? The 2p's. So then the 2p's are involved. Get to the end of the second row. You come down to the beginning of the third row. What block are you in? 3s. You're still reading left to right. What do you come into next if you're on the third row? 3p. Come down to the next row, 4s, then the 3d. So you don't have to remember that little chart on the back with the circles and the arrows. Your periodic table fills in order as you read it, left to right, top down. Okay? So, how many blocks, how many elements into the 3D is iron? 6. Beautiful. So everything else is full. Wait. Okay. You okay with that? Is that?
No, it's not on.
2 more. Wait. Guys. 6. Okay. What I want you to do, I'm going to post a couple of the questions that I assigned, but I want you to do 2 things for me. I want you to draw the electron configurations for the 2 possible ions for iron, and then tell me which one is most stable. I'll post this on Schoology. Have a great day.